All right, here we go, guys. So this is going to be probably a couple videos. I'm going to have to stop probably after 15 minutes or so. But the goal today is, last time we talked about center of data. Today we're going to continue and talk about spread. Okay, and we've talked about that already, but there are some specifics that we might have missed last time. And so I want to be sure that we get those all in. Also, for one of the homework questions, we have to talk about what a z-score is. Okay, so I'm going to give you that definition right now before I forget. And it's basically the individual value minus the mean of the data set over the standard deviation. Okay, and this is z. We'll talk about it definitely more when we do normal distribution. But what it is, this is called a z-score. Okay, is it's basically a standardized variable. It's a distribution that has a center of 1 and the standard deviation is 1. So if you have a z-score of like 0.75, right, that means that you're moving 0.75 standard deviations from the mean. Okay, if you have a z-score of -3, it means you're moving, that's actually pretty extreme, but you're moving 3 standard deviations from the mean, but in a negative direction. Okay, so I just wanted to get that out there, and we'll talk more about it, but it does show up, I think, as one of the multiple choice problems. Okay, warm up. So for this, I'm just going to ask you to pause it and try it. We want two things. We want what's the new mean and what's the new median. And the key things that we have are the mean salary being this and the median salary being this. And then obviously we have this number of interns and teachers and administrators. And it's weird, but this problem looks familiar, so maybe we already did it. So pause it, take a shot at it, and then I'm gonna go over the field notes and show the answer. Okay, so for the answer here, basically, if we wanna find the new mean, we have to know the total number of the total amount of earnings, and we can divide by the number of employees. Okay, so from before, we knew that the mean salary for all employees was 40,300. So we can take that number, we can multiply by 104, because that's the total number of people that work, and we get this number, 4,191,200. Okay. Then to that, we're gonna add 84 times 800. Why? Well, because all the teachers get an $800 raise, and so there's 84 of them, okay? So the new total amount of earnings is this number. We take that, we divide by 104. Here's our new mean, okay? So it's gone up from 4,300 to 4,946, okay? The new median, and this is a property of medians. Well, actually, I should take that back. But the new median is going to be 36,800. And the reason we know that is because if we look at the 104 employees, we have 10 making the low end, teachers making the middle end, okay? And so the median value is going to be in the teacher salary, somewhere in here. And we know it's 3,600, okay? If every one of the teachers get an $800 increase, then every salary gets an increase. So the median salary will get increased by 800. Okay, so hopefully that makes sense. Let's keep going. Okay, so percentiles, we've seen this before, but here's a definition, right? And the key is sort of the same wording as a cumulative density function, below a particular data value, okay? So if you're in the 80th percentile, right, that means that 80% of the data is below that number. If you are in the 0th percentile, then 0 data lies below that. And so that's not a good thing, okay? And again, this is what a cumulative relative frequency gives, okay? But that's a percentile. Here's another warm up. All right, so we have a box whisker plot. Sorry, I didn't want to do that. I want to use the laser. Got a box and whisker plot. And then we got a CDF. We have these questions, pause it, take a few minutes, and then we'll talk about it. Okay, hopefully you've gotten through that. And so if we look, scoring below 73, well, and again, these are going to be approximate, right? But we can go over to the 73. That's the number on our x-axis. We go up, and then we go over. We had this as about 165, right? So that was our answer to A. If you needed a pass mark of 55, what percentage of students passed? So same idea, we can go over here, shoot over there. That looks like 30 or below. So that means that 270 over 300 is 90% of students pass, so that's good. 60th percentile of the scores. Okay, well, so now if we want the 60th percentile, we've got to take 60% of 30, which is 180. And then we can go over here, mark that value, do it better than we've done here, drop down. You know, it looks right around 75. Okay, so the 60th percentile, the value which 60% of the students got below was a 75. Median and quartiles, we're going to do from, the middle value, and then the middle of the middle, so the 25th percentile, and the Q3, quartile 3, the 75th percentile, right? So we could find all those values and get estimates for what those scores were. I guess, yeah, let's do one. So let's see, what's 25% of 300? That's 75, right? So if we go over 75, looks about there. So this looks like maybe a 62 or so. If we go to 75, so that's going to be 75th percentile. It's going to be 225, right? So that would be here. And that looks like exactly like an 80. And now over here we have scores, but in a different way. So maybe we look, at max min, the min value here was 40. That's the same as that. The median here is 78. Our median was, I think, 70, what was it? No, our median would be a little bit lower. It's like 72. So we could say they have the same max and min. And the median is higher. And that was a 78 for a different school. Geez, sorry guys, that is some pretty poor handwriting. So here the median is a 78. Here the median is about a 72, right? So there you go. Okay, another question. Matching, right? Histogram with CDF. So you can do this however you want. You can write A, B, C, you can write these below, matching the numbers. You can draw arrows. But we have some different shapes and we want to know which matches. Okay, so if we look, well, yeah, but let me get the laser. So here we talked before about, you're basically, your cumulative frequency graph is rising very rapidly at first, and then it's kind of tapering off, it's flattening out. So that means that you're adding less and less data. So that makes sense that this A would match to 2. Okay, this is gonna match to here. Here, you got the opposite. You kind of have low data for a while, and then it just spikes up, which means you have a lot of data on the far end. So this is gonna match with this. And then here we sort of have this idea of concavity. So we have increasing, flattens out right around here and starts decreasing. So we have sort of the max amount in the middle with a little on each side. And so that best is like here. Okay, standard deviation, yeah. So this is a big measure of spread. Okay, so this is a measure of spread. And we usually use it with the mean. Okay, so they usually go hand in hand. And basically what it is, right, is it's the average distance. Sorry guys, I hope he makes you laugh. Average distance, a data value is from the mean. Okay, it's an average distance. So like, here we have the data value and we have the value of it minus the mean. So if x is 2, and then it's -4 away from the mean. So, right, we're assuming here that x bar in this case is 6. Okay, now the problem is if we take positive and negative values and we average them, we're gonna get 0. And we can see that here because we have -8 and +8. All right, that's the definition of the mean. So what we're gonna do is we're gonna take all those values and we're gonna square them, because now that gives us a positive number. We divide that number by the total number and we get 12. And then this is actually called the variance. This is called the variance. And then when we square root it, we get the actual standard deviation. Okay, so you're probably not gonna have to do this on the exam. It's good to know, but the calculator will compute this for you. Yeah, and then we have some notation. So this means a population standard deviation. That the population means the whole, all the data, right? All the data in whatever your population is. S, this represents a sample, and a sample is part of the population. Okay, and the sample standard deviation will always be bigger than the population standard deviation, because in one, so in this, that's not good. In this, we divide that whole sum by n minus, just thinking guys, divide by a smaller, yeah, we divide it by n. In the sample standard deviation, we divide by n minus 1. So we divide by a smaller number so we get a bigger result. It's just like an error correction. And there you go. There you see the formula, right? So it's just some notation, right? If we have a sample, we represent the mean as x bar, and the population we represent it as mu. The data values are little n for the sample, big N for the population. Again, here's what I'm talking about. Dividing by n minus 1 versus n. Okay, so this will always be a bigger number because it's approximation. So we just want to be a little safe. If we have all the data values in the whole population, we can divide by n. But yeah, it's just a difference in how we compute it. Here are some reasons why standard deviation is important, right? It gives us a different measure of the spread. If we have some sort of distribution like a normal distribution, we know the width of the distribution, right? So for example, we could have, we could have the same data. Let's say that this is a test, and so we have an average of an 84, pretty good result, but the standard deviation is 15 versus maybe another class that has the same average, right? But for them, their standard deviation is like 5. So it's a lot narrower. Okay? So it tells us more information about the data. All right, I'm gonna do outliers and then I'm gonna stop because we're on page 11 and I wanna make another video just to break things up. So here are the way we test outliers, okay? Outliers are basically, they're very large or they're very small compared to the rest of the data or most of the data, okay? And so what we do is we have these two boundaries, right? And the way we find it is we take, for the upper boundary, we take the upper quartile, which is Q3. Q3, and then we add 1.5 times the IQR. Remember the IQR is Q3 minus Q1, okay? And if we have a number that's bigger than that, that number is an outlier. If the number is exactly equal to this, it's okay. It's not an outlier, all right? The other one is we take the lower boundary, or we check a lower boundary, and we take Q1 minus 1.5 times the IQR. And again, this is Q3 minus Q1. And if a value is less than that, it's an outlier. Okay? So we have, again, Q1 minus 1.5 times the IQR. Up here we have Q3 plus 1.5 times the IQR. Okay? I think, actually I'll stop here, right? So center and spread, we always, when we want to talk about that. If we're using the median as our center, we're gonna go with IQR or range, okay? This is your box plot. This is the 5-number summary. Okay, if we go with center as the mean, then we want to use standard deviation. Okay, and that is the end of video 1, guys. I will see you very soon, hopefully in person, but very soon on the next video. All right, see ya.